Okay, technicians, let's journey into variable cam timing. Now we're specifically going to talk about the double overhead cam motors. Now, it's no secret, first of all, oil level is critical. It can't be low in oil. Oil pressure is also very critical. Typically about nothing below 12 psi, park idle, no load, on a fully warmed up engine, and of course oil condition. Now, we're going to use oil pressure to control the position of the exhaust and the intake cam timing. Now, the nice to know falls in the category, the exhaust cam timing at idle with a 0% duty cycle command to the control solenoid is in a full advanced default position. When you come off idle, at PCM ramps up the duty cycle command to the actuator control solenoid, what we're going to do is we're going to retard the exhaust cam timing. The intake cam timing is exactly opposite. Park idle, no load, the intake cam timing defaults to full retard position, and off idle as the PCM ramps up the duty cycle command to the control solenoid, the intake cam timing advances. Now, the logic here is the fact that on exhaust cam timing, when you come off idle, and the PCM retards the exhaust cam timing, what it does, it leaves the exhaust cam or the exhaust valve open after bottom dead center of the power stroke, which means on the intake stroke, the cylinder pulls in some exhaust gases, and that's how we got rid of EGR. On intake cam timing, when you come off idle and the PCM here again ramps up the duty cycle command, we're going to advance intake cam timing, and actually improves the volumetric efficiency of the engine. They actually breathe better. We'll talk about that in detail a little bit later on. Now, when you take a look at the control solenoid, this is a solenoid controlled spool valve. Now, you guys have pulled these out before, and there are screens in the passages that are known to get sludged up. And typically, what we also see in the industry, sometimes the solenoid windings go open. If you take an ohm meter and an ohm out across the two terminals, 8 to 12 ohms resistance at room temperature is what you should see. A lot of times you can clean these solenoids. If you look at my end cap, you can take a metric Allen wrench and pull off the end cap, tap the solenoid on a bench, the spool valve will pop out, and you can internally clean it that way as well. Sludge buildup, I don't have to tell you, is a major problem when causing these solenoids to stick. It causes the cam to stick in a full advance or retard position. Lights the mill light obviously will set a cam variance type code. Now, when you take a look at the early systems, like on a 4.2 liter Vortec motor, that was the early system where we only varied the exhaust cam timing. In the later years, they came out with double overhead cam motors, and they varied both. Here again, the exhaust cam timing and the intake cam timing. Now, the good news is that in the event that you have a sloppy timing chain or maybe a timing chain that's jumped, you can now use the scan tool parameter called cam variance on a GM vehicle. Most of the GM vehicles that are equipped with variable cam timing, they're only going to allow you plus or minus 5 degrees of cam variance. Now, what we're going to do on a hands-on a little bit later on, we'll actually look at that parameter on the scan tool. The cardinal rule is that when you look at the cam variance, and remember the spec is within plus or minus 5 degrees of zero, is that the RPM has to be rock stable. If you're blipping the throttle and the RPM is changing, you'll see your cam variance parameter on the scan tool jump all over the place. But let's say you look at the cam variance maybe at idle, steady RPM, or 2,000 RPM, steady RPM, and again, you need to be within plus or minus 5 degrees of zero. Now, continuing on, when we go the hands-on, we're going to monitor the variable cam timing data for both the intake and the cam timing on this Aquatech motor. And then we're going to take control of the solenoids with the scan tool. We can command in 10, 20, 30% duty cycle command. We can monitor if the cam moves, and while we're doing that, we'll monitor the cam variance as well to make sure we are within plus or minus 5 degrees of zero. As I said earlier, oil pressure is critical. Most of you technicians have an oil pressure test kit. You know, keep in mind that you need the adapters. A lot of vehicles use metric pipe threads, where GM uses national pipe threads. The Chrysler systems use British pipe threads. So, you know, if you buy a good oil pressure test kit, make sure you have the adapters that's going to apply to every make and model out there. One of the things I pointed out here is that most of GM vehicles no less than 12 psi oil pressure at idle on a fully warmed up engine. If you have low oil pressure, there's not enough oil pressure to phase the camshafts, and you can easily get a cam variance code from lower oil pressure. In addition, oil sludge buildup again is a very common problem.